You're watching The New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show.
Arm Neoverse ecosystem gives chip designers, cloud providers, and software developers the freedom to optimize technology for cloud workloads. Now available for running applications in every major cloud, ARM-based instances offer increased scalability and up to 40% improvements in price performance.
Hey everyone, we are at KubeCon in Salt Lake City. So excited to be here. Today I am talking with Pranay Bakre, a Principal Solutions Engineer at ARM. Hey, Pranay.
Hey, Alex.
ARM is pretty hot, and so I'm curious about how hot it really is. And so when we were chatting a little earlier, you were saying that ARM instances are offered by all the major cloud service providers. Can you talk a little bit about that? And then that would, I think, help us level set on where we are today. Maybe in that you can provide some context, about the history of ARM on these different cloud services, because that gives us a picture of what people can actually do, and then we can get into that depth. We're also going to be able to see a video at the end of this discussion, so we'll get to that when we finish up.
Before I get into that, my job is to help developers build, run, and migrate their applications to ARM and run as seamlessly as possible. And in terms of ARM adoption in the cloud, so ARM Neoverse is our CPU in the cloud, or the server class CPU, if you may. And we started this journey a few years ago, and now all the hyperscalers like AWS, Google, Microsoft have ARM-based instances.
Oracle does too, don't they?
And Oracle too, yeah. So they have in the cloud. Like for example, AWS has Graviton, which is the processor family based on Arm Neoverse. Similarly, Google has Axion, which is again ARM-based processor, and Microsoft Azure has Cobalt 100, which is again ARM-based processor family, right? In that respect, we see that all these cloud providers are supporting ARM-based instances in the cloud. So we are seeing a lot more deployments in this ecosystem because we have built that ecosystem for years, and all the software ecosystem is present to support your migration journeys and your native application deployments to ARM.
That's really interesting because that speaks to the state of the market, doesn't it? And those deployments that you're seeing must be quite varied, across the different cloud service providers. Are there any key themes that come to mind when you think about the deployments on these different cloud service providers?
Right, so a couple of different things. So one of that is around the ARM architecture is power efficient and cost efficient by design.
Yeah.
And that's one major reason where people are choosing ARM as a first target to deploy their workloads. Now, another one is that there are some legacy architectures where people have deployed their applications and they're looking to migrate over to ARM. So now they are thinking about, ARM has so many different capabilities in that architecture built in, and all these cloud providers are offering these instances. How do we get on that? How do we migrate those applications to ARM? So those are some aspects of it are technical. Some of those are different decisions that are being made, but those are the things that we see. And in addition to that, in terms of software ecosystem, all the major software players are supporting ARM native binaries in the cloud. We are here in CNCF, or we are here at KubeCon. So in CNCF, over 95% or 90 to 95% of projects of both graduated and incubating projects support native ARM binaries and support deploying their software around.
That's cool. I mean, one of the questions I have is about Arm Neoverse. Can you talk a little bit about Arm Neoverse and how it plays into this story?
Right. So Arm Neoverse is our server class CPU design. Arm has different class of CPUs, but we are talking about Arm Neoverse, which is the branding that goes in. That's the one that the cloud providers use in their servers as Arm CPUs. So when I mentioned AWS, that's the Graviton instances. Those are Arm Neoverse powered instances. Similarly, Google has Google Axion Neoverse powered, and Microsoft Cobalt 100, which is again ARM Neoverse powered instances. And how it plays in is that's a server class CPU. So the applications in the cloud can be deployed and scaled because it supports that architecture.
When you're thinking about, the people who are using, ARM or migrating ARM, who were some of the earliest users that you saw when you first started working with the cloud services, cleared services? Who were the people that were coming forward? Who did you see from the DevOps community come forward? Who did you see from different communities, that were using cloud services already?
So there were multiple. So if we talk about CNCF projects, I think we worked with HCD, we worked with KubeCon. Those are some projects that we have enabled. We worked with Linkerd from Buoyant. We did a co-blog a few years ago, and that was another use case that did. We worked with Istio. There is, again, different projects that we use and kind of help. In terms of adoption, so these projects that I initially mentioned, HCD, KubeCon, we help them with their migration journey, or not just migration, building ARM-based binaries in their own native pipelines. We provided them with engineering support. We provided them with hardware access to build their CI pipelines through a program called Works on ARM, where we offer free GitHub credits, where they can use those credits to build natively on ARM.
And individual personas, what would you hear from DevOps engineers when they came to you? What would they say?
Right. So it would be in terms of that, can I build my CI/CD pipeline? Can I run my Kubernetes cluster on ARM? And both of those questions the answer is a simple yes. And what we are doing is, what we have done so far is, in terms of CI/CD, we have support for all these DevOps tools, or CI/CD tools, GitHub, with GitHub Actions. We have native runners, ARM-based runners. So in your pipeline, you can build both x86 and ARM-based pipelines, and eventually you can build your entire pipeline just for ARM. We have GitLab runners that are supported on ARM, even managed services like AWS Code Build, AWS, Azure DevOps, in Google, all those different CI/CD practices are supported on ARM. Now coming to Kubernetes, in this example, again, all the major hyperscalers support ARM-based instances, AKS, Azure Kubernetes Service, GKE, Google Kubernetes Engine, EKS, Elastic Kubernetes Service. All of these support native ARM-based instances, and that's what we tell to DevOps folks and individuals, that just go and try to deploy it. All it takes is changing that instance name, and you can deploy your cluster.
So if you were going to explain how to migrate to ARM,
right?
What would be the foundations of your story?
Yeah.
And we talked a little bit about this before. It comes into test and other factors.
Right. So when you are starting your migration journey to ARM, right? And I'm talking about Arm Neoverse and in the cloud, right? You think about three main steps that you need to think about. One is you plan, you test, and then you deploy. And when you say plan, you plan your workload transition. You survey your software stack, meaning that if it's a software stack that it's a Java-based software stack, it's a Golang-based software stack. There was so many improvements we have done over the years in even using Linux distributions like Ubuntu or like RHEL. There were compilers that we have improved over the years. If it's a language-based like Java, use the JDK 17 or something. And we have done, over the years, we are doing year over year, starting with JDK 11, 12, 13, 14, and 16. And all those improvements that we have done so far come into play when you're thinking about migration journey. But the good part is you don't have to think about all those improvements because it just works. So when you're planning your software stack, we have a resource called Software Ecosystem Dashboard. Go to the dashboard, type the package that you think that your application has. You'll see that, it's supported, when it's supported, and what's the version that you can download, and you can just run with it. Someone actually earlier at the booth that, hey, does PHP support it or not? I'm like, yeah, just go ahead and check this dashboard, and you'll see. I'm like, that's really cool. I really needed that, right? So that's step number one. Survey your software stack and see how it's compared, how it's, built out, what are the components, and then go to the dashboard and do that, right? So that's first, the planning stage. The second is the testing stage, where you take out your application, you deploy it on ARM-based instances in the cloud. If let's say it's a Java Spring Boot application, right? So even in that, there is two-step process, a top-down and a bottom-up. So top-down is generally for interpreted languages like Node.js or for Java or for .NET. And you deploy it, you'll see that, I have a Spring Boot application, but it's using a native GNI call, which is x86-1. So you just change that, and then you come back and you deploy, and you'll see, it's already done. I didn't have to do like a lot of heavy lifting just to do that. And the second one is bottom-up approach, where you take apart your stack. Let's say it's a C++ based application. Then you need to recompile those applications and build it again and make sure that they are running, and then you're good to go. That's step number 2. And again, we have so many resources available across different on our websites. And the third step is deploy. Then it's eventually, once your application is doing well, you do a canary blue-green style deployment in the cloud. Again, major hyperscalers or cloud providers support that. And then you slowly divert your application traffic to that, and then your users will enjoy the benefits.
So what other questions have you been hearing at the booth at this show? Are they different than other shows at all? Are you hearing more, I'm sure, about AI?
Yeah. Some of those are mostly around migration.
Right.
There is some around AI. We have announced earlier at another conference about Clyde AI is our set of libraries and frameworks, and that's optimized for AI. We have some partnerships that we are doing in different communities to kind of get that message across. The other thing is, again, I think I touched upon migration a bit, but how do I build, if let's say, since we are again at Kubernetes, so the earlier examples that I talked applies overall, but let's say at Kubernetes, right, you have a big cluster that you're running your applications, and you want I have a Docker container, and I don't know if it's compatible. No need to worry. If it's, let's say, a Java-based stack, all you need to do is in a Docker file, just change a few simple changes, 1 or 2 line changes, and now your application can run both on ARM and x86. Now, in your cluster, in a single EKS cluster, you can have a existing cluster, you can add ARM-based nodes to that cluster, and your application will be deployed seamlessly across both architectures. So it's like a low barrier of entry, and that's what we are also talking about at the booth. So you don't need to think too much. Just start your journey, and you'll get the benefits.
Are people asking at all about what's to come? Who are those who might be using ARM? Are they asking those kinds of questions?
Yeah. So there are a lot of people who are already into that journey, who are already progressing well, who are already running thousands of workloads.
Yeah. What are the things that they want to see?
They want to see more. Like, for example, what's the new generation is going to come, and I'm sure there's going to be tied to the hyperscalers and when those instances come out. But recently, Google Axion got launched, and all of these cloud providers have different up to 60% performance benefits of a particular workload over the either legacy architectures or all the previous generation architectures, right? So those are the benefits people are seeing, that, I want to optimize my application more, and I want to make sure that it gets the best performance that it's possible from that infrastructure.
Are there particular aspects of the performance that they're wanting to see?
So again, it depends on the workload.
Yeah, but like anything in particular that comes to mind? About performance, like performance things that they're trying to achieve?
Not in particular, but I think I can generalize it and say that they are getting really good performance. We have a lot of different benchmarkings that we have out there that people can just go and look. But
I'm asking more like, what do they want to see? What do they wish they could really have, in their ARM deployments now that they'd like to see more of in the future?
Oh.
Are there wish lists that you're hearing from people?
I think more AI is like one of those things, and we are doing that. So our messaging is inferencing on CPU, and again the Clyde AI that I talked about. But more AI, what can we do in there? And we have some more projects that are coming up. We have different resources again available to kind of help with that.
So we're hearing more about inference. Like, tell me about what kind of questions they're asking about inferencing.
Right. So the first question, someone came in and like, can I do inferencing on an ARM CPU? I'm like, of course you can. And you can. We were actually doing a demo at the booth, and we are like, this is what we are doing. We are running. You can do inferencing on ARM CPU on different cloud providers, and then again depends on what kind of things they want to do with inferencing. So it's like a case dependent thing. But yeah, in general, yes. The answer is yes. You can do.
So we've gone through the foundations of the story. What kind of things people are asking for? What kind of things they would like to do? Everybody faces challenges in their cloud infrastructure, right? They all have different components in their software stack, right? They are always trying to find better ways to decrease latency, for instance, for better performance.
Right.
They're trying to manage their Kubernetes clusters more effectively, which is difficult for them to do.
Right.
What do you say to people when they come by and they're talking about these issues? What is it that you could provide them to give them some kind of thinking about how they can approach those types of issues?
Right. So good question. So in terms of cluster management and stuff, right? So I know people use infrastructure as code, for example, and deploy your entire infrastructure using that, like Terraform or Pulumi or something like that. In terms of that, you don't need to do much. If I take example of Terraform, all you need to do is change one line of code, just change the instance type, and then you're good to go. It will deploy your cluster same way as it was. Now, coming back to the latency and performance and those aspects of it, we have different articles and blogs that are out there, which people can go, depending on the workload. They performed much better on ARM compared to x86. And again, those are the performance and cost benefits that they get moving to ARM. That's the key thing to think about, that you can always optimize your application and you can have the lowest latency possible and the highest throughput possible. You need to ensure that your application is running. We have set of examples and collaterals that are out there which show which ones are those, and you can definitely check those out.
There's some hot topics out there. We talked about AI. Another hot topic is platform engineering. Do you hear people out asking how platform engineering, is part of the ARM migration process? Do you hear from a lot of platform teams? Right.
So there is one, and there are people we are helping where they want to migrate to ARM, but they want to see how to set up their entire infrastructure, how we can basically help them achieve much more efficiency in their own workflows. So we have some teams that are helping out those.
Were there any other hot topics you heard about besides AI at the booth over the past few days?
So I think cloud native is one, and again migration, for at least especially from an ARM standpoint, that's the one that I heard about the more. I heard about monitoring as well, but again we have Prometheus and Grafana. They are supported natively on ARM, and you can deploy those in your entire stack and basically see how your cluster is doing or how your infrastructure is doing, and you can monitor all those dashboards.
Are there any aspects of how you think about CI/CD, with ARM?
Yes. So with respect to CI/CD, excellent question. So we have different tools or all these CI/CD tools like GitHub Actions. We have a long-standing relationship with these companies. We recently announced GitHub Actions native runners, ARM-based native runners that are supported. So now when you build your pipelines, you can just say that, I want to deploy an ARM-based binary, or I want to build an ARM-based binary, and you should now be able to do so using those native runners. Now, that's the managed runner that I'm talking about, but even before, there were self-hosted runners that you can actually deploy on ARM. So it's always been there. It's just that now it's more and more around the managed services. So that's GitHub is one example. We have GitLab, which also supports ARM-based runners, self-hosted for a bit. And then cloud providers, the managed services like Azure DevOps, AWS Code Build, all of these support natively ARM-based infrastructure.
How about, infrastructure and hardware access, and, how you think about updating your infrastructure as code?
Right. So again, I'll go back to my previous point where infrastructure as code, it's when you have your existing infrastructure as code, it doesn't take a lot to modify that and make it ARM compliant. And we can help you with that. We have a lot of resources that can help you with updating your infrastructure as code. But if I take an example of Terraform, all you need to do is change the instance type. If you're just launching your infrastructure, I'm sure if there are internal scripts that you need to modify. But if just creating your infrastructure should not be a hard thing to do using infrastructure as code. It's pretty seamless.
Okay. I think we've covered quite a bit of ground. Are there any other resources or things you'd like to add before we get to the video?
Absolutely. So two things. So one is we have, I think I touched upon it a little bit earlier, but ARM has an ARM developer program where developers, and it's free to sign up. Developers can sign up to ARM developer program and it will get you access to different developers. It's a community-based approach. We have Discord servers. We host regular meetups. We do sessions around those. You can join. You can learn more about ARM. You are stuck somewhere. Just go to the Discord and ask someone, maybe myself, and I'll ask the questions. Another one, as part of that umbrella, is called Learning Paths, learn.arm.com. It has a set of how-to tutorials where you can, all the things that I talked about, how to migrate your application to ARM, how to migrate your Kubernetes clusters or your containerized application to ARM. We have those resources. Even in that, the 3 steps that I talked about, plan, test, and deploy, those steps are at learn.arm.com/migration. You'll have much more detailed look what different cloud providers are providing, how you can go about your migration journey, and you can follow that template so forth. I'll say in terms of migration perspective, those are the 2 key resources I'd like to highlight. Oh, sorry, one more thing. One last is the software ecosystem dashboard, which I initially talked about, where you are surveying your stack. Make sure that you go there, see which packages are working, and then you can go down the list. So those are the 3 members.
So just in conclusion, we're going to see this demo, and it's how you migrate from x86-based cloud-native architectures
yes.
To ARM64.
Right, yes. Yeah, so that's in the demo, that's what we are showcasing, how you can migrate your existing x86-based application to ARM64, both in a cloud deployment scenario and in a containerized scenario.
Well, Pranay, thank you so much for taking the time to talk with us today.
Yeah, thanks, Alex. I really enjoyed the talk. Thank you.
Now let's look at the demo of migrating cloud-native applications to ARM. Before the demo, just a little bit of recap of what we had talked about in the discussion. Migration broadly is a 3-step process where you plan, you understand your software, you discover the compatibility between different components of your application stack, and you identify the resources in the cloud where you're going to deploy, be it Google Cloud, AWS, Azure, OCI, etc. Then you test your application using bottom-up or top-down methodology, which we are going to talk about in a second. And then you optimize, you measure your application's performance, and then you fine-tune your application to get the best performance out of it. And then eventually you deploy it in production environment. So these are the 2 approaches that we talked about, top-down and bottom-up. Top-down approach is best suited for interpreted languages or simpler application stacks, meaning that, let's say if you have Node.js application, it's a web server, with just databases, etc., and it's using Java or .NET, for example, for simpler application. Then essentially you can take that application and try to run it on ARM-based hardware in the cloud, and then when you hit the errors, you fix that error and you iterate, and then eventually deploy it. Bottom-up is better for complex application stacks, or which needs a lot of heavy lifting in terms of what different components, or it's using languages like C, C++, where they need to deal with a lot of intrinsics and stuff. For that kind of stack, you take it one layer at a time, and then you migrate it one by one application to ARM. These are some best practices which we touched upon during the discussion. Make sure that you're using the latest compiler versions, you're using the official operating systems distributions for Ubuntu, Red Hat, etc. And again, for application languages like Java, Golang, .NET, Python, etc., make sure you're using the latest one to get all the performance benefits. For containers and orchestrations, all of the major cloud providers support native ARM-based nodes in their managed Kubernetes services. Make sure you take advantage of that. Build your CI/CD pipelines with GitHub Actions, GitLab, using native ARM runners. Do performance profiling, establish a baseline performance, and then migrate your application, and then make sure that your infrastructure as code tools like Terraform, Pulumi, etc. are all updated to ARM-based targets. And these are some resources that we have to help you with the migration. We have migration guides. We have the software ecosystem dashboard where you can find which package supports ARM and which version. And we have learning paths on how-to guides to the demos that we are going to talk about. Make sure you check out these resources. Right, now let's go to the demo. So in this demo, we have a .NET-based application deployed on an x86 environment. And let's say we have different components to it. So we want to deploy it in a Kubernetes cluster that's running on ARM natively. And we also want to implement CI/CD as part of our entire application development lifecycle. So we already have deployed, let's say, an ARM-based cluster with 3 nodes. I'm using AKS here. You can similarly use EKS, GKE, etc. And what we do is we'll see that all 3 nodes are ARM64 nodes here. And we are also going to look at the application and what that looks like or where it's running. So if you see here, this is an application that's running, that's a pod that's running on an agent pool that's ARM-based, right? And we are going to make a few changes to the application here. As you see, I'll look at the target framework. I've already changed it to .NET 8.0. It was using an older .NET framework before. And we will also change a couple of few things along the way. But right now, let's just make a simple change to the repository. So, and commit it. So it's going to trigger the build for us using GitHub Actions. So I'm using GitHub Actions that's based on ARM, an ARM-based runner to be exact. And we are going to commit this change to the repository. Now, once we commit our build, right, let's see, yes, so the changes, okay. And now let's go to the repo in GitHub and see if our build got triggered. So if we come here, there you go. So it's already started deploying that application. It's using ARM-based, native ARM-based runner in GitHub Actions. And here I'm just showing the cluster and the repo where it's going to deploy build that we are going to look at it. This is showing the repository where it's going to deploy that image of the cluster. And now we are going to look at the tags. And if you see here, the platform is ARM64. So it already has built that image. And if you can see, it shows the tags and everything. And we come back and see that it's already done. Now, this is already deployed. So we made very few changes, which we look at it in the GitHub repo. So if you come here and you see this is my GitHub YAML file where I'm using a few jobs to deploy it. I'm using a self-hosted runner, but the managed ARM-based runners are also supported natively on ARM. I'm using Docker build. I'm pushing this Docker image to the registry, and I'm deploying it on that AKS cluster. I'm using the deployment YAML and the service YAML. Now quickly, let's look at the Docker file. And I'm using standard .NET commands, .NET restore, build, and publish. It's going to publish natively as an ARM target. using the GitHub Actions runner natively on ARM. And now let's look at the application again and see it should have deployed the new pods. It was running an hour ago, and let's see. Right, so it's already updated it, and it's deployed it. So that shows how you can entirely build your application natively on ARM, how you can migrate an existing .NET-based application and build your entire CI/CD lifecycle natively on ARM, and you can do your deployments in canary-style fashion. So I've used a very generic example. So again, everyone's case would be different, but this is just to show how do you migrate an existing application to ARM in a step-by-step fashion. Thank you.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.